Hello friends, welcome to session 13 on projection of lines. Here we'll be doing one very good problem what students are expected to know. Once you are thorough with these type of problems, as I've been telling you, you can manage complex problems given in the examination. Okay, now you see here, there is one problem here where NT of the line AB is 30 mm above HP, 20 mm in front of VP. This is not a midpoint problem. Okay, that is it is not midpoint. It is single locus problem only, where one NDA is fixed. NDA is a fixed point. NB is a moving point. It is not a midpoint problem. Okay. Okay. Now ND of the line AB is 30 mm above HP, 20 mm in front of VP. Okay, this is not a parameter. Whatever they give, you assume. Okay, 30 mm above HP, 20 mm in front of VP. They are given this, you take the same distances. Now you see for the three parameters what should be given in this problem. Line is inclined at 40 degrees to VP. That means this is the phi. That is true length of the line inclined at 40 degrees to VP, but true length has not been given. I think you can understand this. Please analyze. Line is inclined at 40 degrees to VP. It is the true length of the line which is inclined at 40 degrees to VP, but true length has not been given. It is not top view of the line inclined at 40 degree. It is line inclined at 40 degrees to VP. 40 degrees to VP means it is the phi which is given. Phi, Roman phi, 40 degrees to VP. Okay. It is a true length which is inclined at 40 degrees to VP. Okay. The profile view, they for the first time, they given the profile view of this line is inclined at 60 degrees to x1 y1 line and measures 60 mm they are given. For this you have to draw the projections and determine apparent inclinations and all that. Here the profile view of this line is inclined at 60 degrees to xy line. That is one parameter and measures 60 mm. That is also another parameter. That means two parameters here and line is inclined at 40 degrees to VP also. That is the one parameter and profile view is inclined at 60 degrees to x1 y1 line, not xy line. Please remember x1 y1 line. Okay, profile view. It is a side view, a left view on right profile plane. Okay, this is at 60 degrees to x1 y1 line and measures 60 mm also. The profile view measures 60 mm. That means this is one parameter, this is one parameter, this is one parameter. In that way, three parameters are given in this problem. Okay, as usual, you draw an xy line, VP, HP you draw. 31 end is 30 mm above HP, 20 mm in front of VP. Okay, draw this 30 mm, 20 mm in front of VP. Okay, now line is inclined at 40 degrees to VP means you can draw 40 degrees, but true, I don't know the true length. I have to stop abruptly. I don't know because I can draw on 40 degree, but where to stop, I don't know. That is why, since profile view is given, I'll directly go for the profile view. Okay, you take any distance. This distance can be anything because the views don't affect here. This distance can be anything. You take any distance, draw x1, y1, draw 45 degree line also. This is VP, this is HP, this is RPP. You are looking from left, the left view on RPP. This they have given. This they have given it as A double dash B double dash. This measures 60 mm. It is not inclined at 60 degrees to XY line. It is 60 degrees to X1 Y1 line. This one, okay. This is 60 degrees to X1 Y1 line. This is the thing. Now, A double dash, B double dash, they are given already 60 mm. This is 60 degree. Two parameters I have already considered. This is x1, y1. Please understand. A dash, A you taken and 45 degree line you meet this. From here you get A double dash. Okay. From you get A double dash. From A double dash, draw A double dash, B double dash at 60 degrees. This is 60 degrees. This is 30 degree. And so that this is 60 mm. Okay. Now, once you do this, you take the projectors down. Okay. That means now you draw a line at 40 degree. Now you take the projector down. Once you draw the projector here, okay, once you draw the projector, anyway it is the locus point because it is the locus in the front view. This is the end point. That means the end point of B, that is end point B, should be obtained here only on this. In that way, since it is 40 degrees is the phi, true inclination with respect to VP, wherever it cuts, this becomes the true length and this becomes the locus. Please follow this. See here, this is the end B. Okay, end B, once you have the end B, this is line is inclined at 40 degrees to VP you draw. Okay, but I don't know the end here. But now since B double dash is known, you come down, meet 45-degree line and come down this way. As a result, if you measure AB1, okay, you are getting the true length. Okay, AB1 if you measure true length. That means this is end B, means this is end B for the side view. This is end B for the top view. Okay, in that way, you are getting the true length. Okay, did you follow? Now carefully watch. You are at this stage, true length is 81. That is in fact is one of the answers for this problem. You have to write true length is 81. And you have to you have to complete the projections. Now since this is the true length of the line, I have been telling you so many number of times, once you find the true length, corresponding other view should be parallel to xy line. Okay, corresponding other view should be parallel to xy line. You draw this corresponding other view parallel to xy line, which you can rotate till it cuts the end projector or locus. Okay, now since B double dash is here, if you take a projector from here, since B dash has to be found here, this itself will be the locus now. Okay, this itself will be the locus. That is why what you do is A dash as center, A dash B1 dash as radius, draw an arc wherever it cuts. That means this is the locus. Okay, this becomes the front view of the point. Front view of the line. A dash B dash. Once you have the front view, okay, from B dash you come down, you get the top view also. From B dash you come down, you get the top view also. The top view of the line is AB. Okay. Now once you know everything here, this anyway, this is phi that was given. Okay. That is the true inclination line with respect to VP that given. But this is beta. You measure this angle. This will be beta. This will be alpha. But theta has not been found out. To find theta, I have told you several methods earlier. One is you have this true length, no? True length is 81. With A dash as center, 81 as radius, you cut here and join here, you get directly theta. That is one method. Otherwise, rotating top view or front view parallel to xy line and hitting against the locus, you will get true length and true inclination. That also I told you. Now you can even rotate the top view here. Rotate the top view here. Rotate the top view. Okay. Now since I've already used B1, you used B2. Okay. Rotate the top view parallel to xy line. In this position, AB2, no? AB2 position. It is parallel to VP. True length is seen in the front view. You hit against the locus. Join A dash B2 dash. In that way, this becomes the true length of the line. Okay. This is, if you're done correctly, this will be equal to 81 only. Okay. Now, this is the theta. That is true inclination of the line with respect to HP. This will be alpha. That is front view inclination of the line with respect to HP. Okay. This is beta, top view inclination of the line with respect to VP. Okay. This is phi, which is given in this problem. Okay. Now we show this alpha, beta, theta, and all that. Make a list here. Make a list here and show it to the examiner. Okay. Now I'll repeat what exactly I have told you here. See here, in this problem, one end is 30 mm above HP, 20 mm in front of VP, they are given. Take A dash and A. After drawing XY line, VP, HP, 30 mm, 20 mm you take. Once you draw this, the three parameters you search out. The three parameters is, one is line inclined at 40 degrees to VP they are given, but they are not given the true length. That means only you can draw 40 degrees, that's all. But I don't know the true length. But what they are given is, side view of the line, okay, left view on RPP, side view of the line is A double dash, B double dash, okay. that they have given it as 60 degrees to x1 y1 line, this x1 y1 line 60 degrees and measures 60. That is why after drawing xy line, a dash a directly go for x1 y1. Okay, x1 y1 you draw anywhere, any distance here, some 100 mm or 120 mm you take and draw x1 y1. Okay, then you take this a double dash you get, from a double dash, b double dash you draw at 60, measuring 60 mm and inclined at 60 degrees to xy line, x1 y1 line, 60 degrees to x1 y1 line. Once a double dash, b double dash you got, this is the locus of b in the front view, and if you come down, this is the locus of b in the top view. Okay, once you know b double dash, you get the locus in the front view, you get the locus in the top view also. Now draw a line at 40 degree. Draw a line at 40 degree because they are given this inclination, true inclination with respect to VP. Draw from A, draw a line at 40 degree. Wherever it touches, that becomes B1, B1 or B2, whatever you call it. That becomes B1. Then measure AB1, which will be equal to the true length. True length 81, that is one of the answers you have found out. Once you get the true length, I have told you in several problems, corresponding other view should be parallel to xy line. Draw a dash b1 dash parallel to xy line. Okay, in which you can rotate till it cuts the end projector or locus. Okay, immediately you cut, you rotate it such that it cuts the locus from b double dash. That is, this is the locus. You rotate it such that it cuts the locus. Wherever it cuts, this becomes a dash b dash, which is the front view of the line. Okay, from b dash you come down, you get b also, which is the top view of the line. Okay, once you have this, you have alpha ready, you have beta ready, but this phi they have already given. But theta we didn't have. One method of getting theta is take true length 81, from a dash you cut 81 here, directly you get theta. Otherwise, rotate the top view parallel to xy line, let us say some b2 position. Okay, b2, in this position it is parallel to vp, no, a b2 position, it is parallel to vp. In that way you can find the true length in the front view, then hit against the locus b2 dash. In that way a dash b2 dash, if you are done correctly, it will measure 81 only. In that way theta also you measure. List out all the values, alpha, beta, theta, you measure all here. That is, alpha is so much, beta is so much, theta is so much, true length is so much. They are all the answers for this problem. Okay, now we have come to the end of session 13 on projection of lines. We'll continue these sessions in the form of application of straight lines and then the plane surfaces and all that. Okay, thanks friends, thank you very much for watching. Thank you.